Okay, so we have discussed different methods that we can use to solve a quadratic. We started off discussing how to factor, and then we led into how to use the quadratic formula. Well, how do you know when to use what? First of all, when you solve a quadratic, you are trying to find a solution, which could also be referred to as the roots, zeros, or x-intercepts. Now, all quadratics can be solved using the quadratic formula. However, all equations are not factorable. So let's look at a couple of examples together. Okay, so we have this quadratic, 6x squared equals negative x plus 1. Well, hopefully you realize that it is not equal to 0. Regardless of which method you choose, you have to ensure that all terms are on the left side of the equal sign or on the right. So what I am going to do is add the x and subtract the 1. So now we're ready to try to factor. So let's see if it's factorable. In order for it to be factorable, we would need to find two numbers that multiplies to a times c, which would be negative 6, and adds to b, which is positive 1. In this quadratic, a is positive 6, b is positive 1, and c is negative 1. So do we have two numbers that would multiply to negative 6 but add to positive 1? If those numbers exist, then it is factorable. And in this case, they do exist. Positive 3 and negative 2. 3 times negative 2 gives us a product of negative 6, but 3 plus negative 2 gives us a sum of positive 1. So we're ready to create our box. Okay, so when we create our box, we always put the a term in the top left square. So 6x squared goes here, and c goes in the bottom right square. And we found our two numbers, so we have a 3x and a negative 2x. So now let's go row by row and take out our GCF. When looking at that top row, 6x squared and negative 2x, they have a greatest common factor of 2x. In the bottom row, we have a 3x and a negative 1. The greatest common factor is positive 1. So now let's look at the first column. The first column has 6x squared and a positive 3x. So what is our greatest common factor? Greatest common factor would be 3x. And when we look in our second column, we find that we have a greatest common factor of negative 1. So our two factors are 2x plus 1 and 3x minus 1. Now that's the factors, but it's not our solution. In order to find a solution, we have to set them equal to 0. So when I subtract the 1 and divide by 2, I get x equals negative 1/2. And then when I take the 3x minus 1 and set that equal to 0, I get x equals positive 1/3. So we have two x-intercepts, and we were able to find those x-intercepts by factoring. So let's look at another example together. So in this quadratic function, we have 9x squared plus 10x equals negative 2. So again, our first step is to set it equal to 0. So I need to add 2. So when I add the 2, I get 9x squared plus 10x plus 2 equals 0. So A is 9, B is 10, and C is 2. So let's try to factor it. So if we want to factor it, we need to find two numbers that multiply to 9 times 2, which is 18, but add to 10. So let's think about this. The numbers that multiply to give us 18 are 1 and 18, 2 and 9, and 3 and 6. But none of those pairs has a sum of 10. And that tells us that this is not factorable. We can't factor this because those numbers don't exist. So we have to use the quadratic formula. Now, yes, we could have used the quadratic formula in example 1 because every quadratic can be solved using the quadratic formula, but not every quadratic can be factored. So now that we know that this can't factor, I'm going to take away this x, and now we're ready to proceed using the quadratic formula. So b squared, 10 squared, minus 4 times a times c. This is our discriminant. And remember, this is really important because it will tell us how many real solutions we have. So when we type that in our calculator, we get 28. Now that is the part of the quadratic formula that is underneath the square root. So let's simplify that 28. If we were to simplify that using the cake method, we're going to keep dividing it so we can simplify, and we get that we do have a pair. We have a pair of 2's, and we have a 7. So because we have a pair of 2's, that 2 can come out, but the 7 does not have a partner, so it has to stay. So the square root of 28 is equal to 2 times the square root of 7. So let's go ahead and finish out by plugging in the last two pieces of the quadratic formula. So x equals the opposite of b. B is positive 10, so it's a negative 10, plus or minus 2 times the square root of 7 divided by 2 times 9, which is 18. Now this can be simplified a little bit further. Because when we look at our three numbers, excluding the 7, all three of those numbers are even. So we can actually simplify it by dividing everything by 2. So our final answer is negative 5 plus or minus the square root of 7 divided by 9.